Alrighty, here we go, right? So for this guy, you're going to use what? Pressure is equal to pressure naught plus rho GH, because they want the absolute pressure there, right? So they've told you that the atmospheric pressure is this. There you go, right? They've told you the depth, that's the H, right? There's the density. There you go, okay? And then explain what happens to the pressure at Q when the tap is opened, right? When the tap is opened, right, the fluid moves, right? And then use Bernoulli, right? Bernoulli predicts a certain thing happens when the fluid is moving as opposed to when it's still. And if you still don't understand that, Google that. Read about Bernoulli equation, okay? The second part of this is the Reynolds number, right? They say calculate the Reynolds number. The formula for the Reynolds number is Reynolds number, and this is based on the radius, right? Is viscosity is in the denominator, right? And then density and radius and velocity are in there. So all inertial things are on the top. Viscous forces are on the bottom there. Okay. Why it's 2 marks, I really don't know. I believe you want to use the actual radius here, right? So this is the diameter, so be careful about that. Although in another test, I believe they use the diameter, so and give the radius as an alternate answer. I just don't know. I'm not an engineer. Okay, explain the significance of this value, right? Onset, if R is about 1,000, that's the onset of turbulence. If a Reynolds number is around 10,000, it's fully turbulent. So talk about the turbulence. Laminar flow is that everything moves in more or less straight lines. There's no eddy currents, right? Turbulent flow is, like I showed you, right? Okay. Yeah. And remember that we need laminar flow to use Bernoulli's equation. Okay.